In 2020, Elon Musk confidently declared that his company would land the first human on Mars by 2026. Now, it's 2024, and from what we can see, Musk hasn't had much luck in achieving this goal. With just 2 years remaining until his predicted date, the prospect of seeing a human on Mars is, to put it mildly, unlikely. Meanwhile, NASA seems to be in no hurry, as they are only now planning new missions to the Moon, and even these missions are frequently being postponed. So, what went wrong? In this video, you'll learn why it is so hard to travel to Mars from Earth, why we have already traveled to the Moon but not yet to Mars, how and when travel to Mars is planned, and how we are going to conquer Mars. Please like this video and subscribe to our channel for more fascinating educational content. For most people, conquering Mars means at least having a person fly there and plant a flag, or building a base with regularly rotating staff, like on the ISS. Others dream of terraforming Mars, deliberately changing its conditions to resemble Earth. Whatever people envision, for now, even the idea of flying to Mars and planting a flag is an extremely challenging task. It would be a great achievement if the first interplanetary astronauts managed to reach the red planet and return to Earth successfully. Successfully means alive and preferably healthy, though even the smallest health risks are a concern for such a long and dangerous journey. But why is it so difficult? After all, humans landed on the Moon more than half a century ago. Sending a person to Mars is, to put it mildly, not the same as going to the Moon. The task is far more complicated, and we will now show you just how vast the difference is. Let's take a step back to better understand the challenge. A human first set foot on the Moon on July 20, 1969. This wasn't just a symbolic gesture to plant a flag. People worked there, 6 manned missions in total, and 12 people were lucky enough to walk on its surface. It took just 7 years from the goal's announcement in 1962 to the landing of a human on the Moon, which is incredibly fast. The question is, what's wrong with Mars? Why hasn't a single person been there in over half a century? Despite all of Musk's optimism, even he admitted in an interview with entrepreneur and space adventurer Peter Diamandis that a bunch of people will probably die in the beginning of Mars missions. It's tough sending humans there, he says, but we're an exploring species. To understand the scale of the difficulty, imagine walking to a shopping mall 1 kilometer, about 0.6 miles, from your home and back. It would take you about half an hour, and you could comfortably make the trip in slippers, probably without getting tired. Now, imagine walking not 1 kilometer but 140 kilometers, about 87 miles, and then the same distance back. That's roughly how a flight to Mars compares to a flight to the Moon, but it's many times worse. The distance to the Moon is stable at about 384,000 kilometers, 238,857 miles, while Mars is at least 56 million kilometers, 34.8 million miles away, which is about 140 times farther. The minimum distance is constantly changing due to the planets orbiting the Sun at different speeds. At some points, Earth and Mars can end up on opposite sides of the Sun, increasing the distance to 400 million kilometers, 248.5 million miles, 1,000 times farther than the distance between the Moon and Earth. With modern technology, a one-way flight to Mars could take 7 months, or even nearly a year. The enormous distance is the main issue with any manned mission to Mars, and many other problems stem from it. During all those months, the crew would need to eat, drink, maintain hygiene, monitor their health, and perform daily tasks in a confined space, all while dealing with breakdowns, cosmic radiation, and no chance of receiving immediate help from Earth. Even getting simple advice from specialists on Earth would be delayed by 10 to 20 minutes, depending on the current distance. Can we somehow assess the likelihood of such a mission's success? Let's take a look at past Mars missions. In over 60 years, 48 missions have been sent towards Mars, including those that didn't involve landing a probe or rover. Of these, 26 missions failed. Even unmanned, the chances of a mission's success are almost 50%. Considering all of this, Elon Musk's words about the likely deaths of the first Mars explorers sound frighteningly convincing, especially coming from Musk, who is widely known for his optimism about Mars exploration. However, humanity does not intend to give up. So, let's stop with the pessimistic thoughts for today and focus on how the optimists plan to get to Mars. The first problem NASA faces in its quest to get to Mars is actually taking off, getting out of Earth's powerful gravitational pull. This depends on how much equipment needs to be carried along. Take a look at the Space Shuttle, which performed manned missions to Earth's orbit. It's a huge rocket, 56 meters, 183 feet, long, but even it looks like a toy compared to the Saturn V rocket, which delivered humans to the Moon. One can only imagine what a monstrous rocket would be needed to lift all the enormous supplies and equipment required for a mission to Mars. NASA decided that the first manned mission to Mars won't start from Earth but rather from a place with no strong gravity, like the Moon's orbit. By the 20th mission, NASA and its partners will have developed enough lunar infrastructure for astronaut teams to stay there permanently and feel at home. This will mark the first historic step toward making the red planet much more accessible and the plans for its colonization much more realistic. We are talking about the construction of the first orbital Martian station in history. Lockheed Martin, the corporation that created the Mandarin spacecraft, presented the Mars Base Camp project in 2016. The concept includes a Martian orbital station that can accommodate up to 6 astronauts. Having a station in Mars orbit will significantly accelerate the process of actually traveling to the red planet. Before attempting to land on Mars, though, some conditions must be established for the first explorers. According to NASA's plans, the conquest of Mars will be carried out in 3 stages. In the first stage, some essential equipment will be sent to Mars in advance before humans arrive. These units will initially be delivered from Earth to the lunar station and then to Mars. It's likely that the first surface power system will be deployed on the red planet, along with fuel supplies and equipment for fuel transfer. This will help the future Martian base become energy autonomous and independent of sunlight, which is crucial because any prolonged dust storm on Mars could cause significant problems. According to estimates, the total weight of the essential cargo will be tens of tons, orders of magnitude more than any automated mission to Mars has ever undertaken. In the second stage, a special module called the Mars Ascent Vehicle, MAV, will be sent to Mars's surface. This vehicle will bring astronauts back to Mars orbit. It will be compact, equipped with rocket engines capable of overcoming Mars's relatively low gravity, and will carry people and cargo into orbit. Finally, in the third stage, astronauts will fly to Mars from the lunar station aboard the Deep Space Transport spacecraft, which will be equipped with the Transit Habitat module. This module will provide astronauts with sleeping quarters, work and rest areas, air and water regeneration systems, and radiation protection for long space missions. The trip will take 10 months, after which 2 astronauts will descend to the Martian surface while 2 remain on the orbital station. The astronauts will use a specialized landing module to descend to the planet's surface. This module will be pre-delivered to Mars's orbit and ready for use when the crew arrives. Essentially, this will be both a vehicle and a home for the astronauts. NASA's idea is to combine the first Martian home and transport vehicle into one rover equipped with an air supply system. This will reduce the number of items needed for landing. Extensive testing has already been conducted on prototypes of this rover, which resembles a van and will be fully equipped for the crew's living and working needs during their stay on Mars. Once the astronauts collect their samples, they will return to the MAV, which will bring them back to Mars's orbit. The crew will spend around 60 hours traveling to the orbital station, where they will transfer to the Deep Space Transport. From there, it's a 17-month journey back to Earth. Upon reaching high Earth orbit, the Orion spacecraft will meet the crew and bring them safely back to Earth. The entire Mars flight epic relies on timing. We can only travel to Mars during specific windows when the planet is at the right distance from Earth. The trajectory must be calculated so the spacecraft and Mars meet at the right point in space. There are 2 such windows, conjunction class and opposition class. The conjunction class trajectory requires less fuel but takes longer, 900 to 1,000 days, with 400 to 600 days spent on Mars. In contrast, the opposition class trajectory requires more fuel but shortens the expedition time to 560 to 700 days, with about 30 to 90 days on Mars. NASA's perspective on the opposition class trajectory has changed in recent years, as it offers the advantage of reducing the risks of equipment failure and crew radiation exposure. Interestingly, The opposition-class trajectory even involves a gravity assist flyby near Venus. So, when will a living person finally set foot on Mars? According to NASA's current announcements and forecasts, the EMIS program is aiming for a manned landing on Mars by 2039. However, with shifting timelines and many unknowns, the actual date could be much further down the line. One thing is clear: every step forward in lunar exploration brings us closer to the next big step for humanity, life on the red planet.